Welcome to Planetterrian Daily. I'm Patrick in Vancouver, and this is episode 41. Today we're looking at a handful of findings that each, in their own way, show how deeply our health is shaped by both ancient biology and very modern science. Some of these stories feel hopeful, others quietly sobering, but all of them add a meaningful piece to how we understand the human body and the world it lives in. Let's start in the mouth, because sometimes the most practical breakthroughs come from the most everyday problems. Researchers have developed an artificial saliva using a protein called canecpi5 that comes from sugarcane. This protein has a remarkable ability to bind directly to tooth enamel, forming a protective layer that shields the tooth surface from the acids that cause decay. Early laboratory tests suggest it performs even better when paired with fluoride and xylitol, two ingredients already common in oral care products. That synergy is important because it means this new material might not require an entirely new routine. It could simply enhance what many people are already doing. The implications are especially meaningful for people who no longer produce enough of their own saliva. Cancer patients who've gone through radiation to the head and neck or certain chemotherapies often develop severe dry mouth, sometimes permanently. Without that natural saliva, teeth lose their primary defense against acid attacks and decay accelerates dramatically. What makes canecpi5 clever is that it repurposes an agricultural byproduct, something that would otherwise be waste, into a targeted clinical tool. It's a nice example of circular thinking in biomedical research. Of course, we're still in the early stages. The real test will be whether this protective effect holds up in longer-term human trials, whether the material stays on the teeth through normal eating and drinking, and whether it remains safe with daily use. Still, it's the kind of incremental but genuinely useful advance that could improve quality of life for a lot of people who currently struggle with dental damage. While we're thinking about how early interventions can protect us later, another study reminds us that some risk factors are set long before we have any control over our daily habits. Researchers found that low birth weight is associated with a higher risk of stroke in young adulthood, and this link appears to hold even when current body mass index and gestational age are taken into account. In other words, it's not simply that smaller babies grow up to be heavier adults who then have vascular problems. The association stands on its own. This adds to a growing body of evidence that the conditions we experience in the womb and right after birth can program aspects of our physiology for decades. Most of us tend to think of stroke risk as almost entirely a story about the lifestyle choices we make in our 30s, 40s, and beyond. What we eat, how much we move, whether we smoke, how well we manage blood pressure. But developmental programming research keeps showing that the foundation is laid much earlier. The cardiovascular system's sensitivity to stress, its ability to regulate inflammation, even the way blood vessels respond to injury, some of these traits seem to be influenced by the intrauterine environment. It's a bit humbling to realize that as you sit listening to this, the 9 months before you were born are still quietly shaping how your body handles metabolic and vascular stress. The practical message isn't meant to induce worry. It's more of a call to pay closer attention during pregnancy, supporting healthy fetal growth through good prenatal care, nutrition, and reducing unnecessary stress on expectant mothers. For those of us who were smaller at birth, it's a reminder that regular cardiovascular checkups aren't overcautious. They're just good maintenance on a system that may have started life with a slightly different set of instructions. Staying with the theme of early signals, there's interesting new work using artificial intelligence to read the microbiome for clues about digestive disease. Researchers trained AI models to spot patterns in gut bacterial metabolites that are linked to one condition and then used those same patterns to predict the likelihood of other, seemingly unrelated digestive disorders. The results suggest that our internal ecosystems are more interconnected than we usually assume. What starts as a change in one part of the gut can send ripples that show up elsewhere, sometimes long before classic symptoms appear. This approach is exciting because it points toward less invasive, earlier detection. Instead of waiting for tissue damage or advanced imaging, a stool sample analyzed with the right algorithms might one day flag elevated risk for several conditions at once. It also highlights how AI is becoming a genuine scientific partner, not just automating tasks, but helping us see patterns in complex biological data that human eyes alone might miss. We've known for a while that the microbiome influences far more than digestion, but this kind of cross-disease predictive work makes the connections feel more concrete. The next phase will be moving these tools out of research databases and into real clinical settings where they can be tested prospectively. If they hold up, it could quietly shift how we screen for chronic digestive illnesses. The same week we see AI and biology coming together in the microbiome, big tech made another serious move into biotechnology. Anthropic, one of the leading AI companies, has acquired the biotech startup Coefficient Bio in a deal reportedly worth $400 million. This isn't the first time an AI-focused firm has bought its way into wet biology, but the size of the acquisition signals growing confidence that the computational tools developed for large language models can be repurposed to understand living systems. It's part of a broader convergence we're watching in real time. The same techniques used to find patterns in text are now being turned toward protein folding, genetic regulation, metabolic networks, and, as we just heard, microbiome metabolites. These acquisitions tend to accelerate when the data gets rich enough and the computational power is sufficient. We'll almost certainly see more of them. The open question is how this marriage of silicon and biology will ultimately affect the pace and direction of medical research. There's enormous potential, but also the need to make sure these tools are developed with proper scientific rigor and attention to the complexity of real human bodies. While technology companies invest in decoding biology, the planet itself is sending some loud signals from the far north. A long-term analysis of data from northern Alaska shows that thawing permafrost is increasing runoff and extending the period when the ground stays thawed well into the fall. As a result, more dissolved organic carbon that has been locked away for thousands of years is being washed into rivers and eventually carried to the ocean. Some of that ancient carbon is then converted into carbon dioxide, which can contribute to further warming. This is a classic positive feedback loop, the kind that makes climate models particularly tricky. The carbon now being released was sequestered long before human civilization existed. Its return to the active carbon cycle adds a source of emissions that isn't directly under human control. The findings don't mean we should throw up our hands, but they do underscore why accurate long-term projections need to account for these permafrost dynamics. The more we understand the scale and timing of this release, the better we can anticipate how it might interact with our own efforts to reduce emissions. Let's come back down from planetary scale to something much smaller and frankly quite surprising. In a study using Wistar rats fed a high-fat diet, researchers found that milk fat globule membrane material derived from whey protein phospholipid concentrate helped prevent cognitive impairment. The protection seemed to work through two main mechanisms: increased connectivity between neurons in the brain and improved clearance of certain sphingolipids that can accumulate under metabolic stress. What's notable here is the specificity. This isn't a blanket claim about dairy is good for you. It focuses on particular components of milk, the membrane that surrounds fat globules, and tests them in the context of a diet that mimics the kind of high-fat processed eating patterns many people actually follow. The fact that these components appear to buffer the brain against some of the negative effects of that diet is intriguing. It suggests that dairy isn't a single substance but a complex package, and that certain fractions of it may have protective properties we're only beginning to understand. Of course, rat studies aren't the same as human ones, and we need to see whether these effects translate. But it adds to the conversation about how specific food components might support brain resilience even when overall diet quality isn't ideal. Shifting from biology on Earth to discoveries in space, astronomers have identified an entirely new class of stellar remnants. In binary or multiple star systems, white dwarfs often pull material from their companion stars. This accretion process produces distinctive X-ray signatures that researchers have now used to define a new category of objects. The finding also emphasizes something basic about our galaxy. Most stars are not solitary like our Sun. The majority exist in binary or multi-star systems, which dramatically changes their life cycles and ultimate fates. This matters because our models of stellar evolution have historically leaned heavily on single-star assumptions. Recognizing how common these interacting systems are forces us to update those models. It's another reminder that the universe is messier and more social than we sometimes imagine, even at the scale of stars. Back on Earth, a new report from Vanderbilt makes a compelling case that extreme heat is not just a meteorological problem, but a deeply social one. The report notes that heat kills more Americans every year than hurricanes, floods, and tornadoes combined. Yet our response has often focused narrowly on temperature thresholds, weather alerts, and technological solutions like air conditioning. The authors argue we need policies that take cultural context, community norms, living arrangements, and social vulnerability into account. This perspective feels important. Heat doesn't affect everyone equally. Neighborhood layout, housing quality, age, pre-existing health conditions, and even cultural attitudes toward checking on neighbors all shape who stays safe and who doesn't. Framing heat as a social issue rather than purely an environmental one opens the door to more humane and effective preparedness strategies. It's the kind of thinking that moves us from simply issuing warnings to actually building resilience where it's needed most. There's also encouraging clinical news in breast cancer. In a recent trial, the combination of amivantamab with albumin-bound docetaxel given with or without carboplatin met its primary endpoint of pathologic complete response in the neoadjuvant treatment of HER2-positive breast cancer. These results add to the growing toolkit of targeted therapies for this particular subtype, which has already seen dramatic improvements in outcomes over the past 2 decades. It's heartening to see continued refinement of these regimens, offering more options while researchers keep working toward even better tolerated and more effective approaches. On a completely different note, neuroscientists have been studying a woman who can voluntarily enter a trance-like state without any drugs. Brain scans taken during these self-induced episodes showed decreased connectivity in visual and somatosensory areas, alongside increased connectivity in frontoparietal control regions. In other words, she can consciously reorganize her brain network activity in a way that produces a distinct altered state of consciousness. It's a striking demonstration of neuroplasticity under voluntary control. Most of us assume that profound changes in consciousness require external substances or years of intensive meditation practice. This case suggests some individuals can achieve significant shifts through learned mental technique alone. It challenges our assumptions about the fixed nature of brain states and opens intriguing questions about what else the human mind might be capable of with training. Staying with human resilience, a lighter but still meaningful piece of research suggests that a sense of humor can be a genuine asset for older adults. The ability to find and share humor appears to help people maintain social connections, cope with physical changes, and preserve a sense of well-being as they age. It's one of those findings that feels intuitively right and yet benefits from being studied rigorously. In later life, when losses can accumulate, the capacity to laugh may function as a quiet but effective psychological resource. Finally, let's end with something that still makes me smile every time I think about it. Researchers discovered that bumblebees, insects with brains the size of a sesame seed, can learn specific rhythmic patterns. Not only can they distinguish between different rhythms and tempos, they can transfer that recognition across completely different sensory modalities, recognizing the same rhythm, whether it's presented as a light pulse or as a vibration. This challenges long-held assumptions about the neural hardware required for abstract learning. It suggests that sophisticated cognitive abilities can emerge in very small nervous systems when the evolutionary pressures are right. The finding is a lovely reminder that intelligence in the natural world comes in far more varieties than we usually credit. Before we wrap up, it's worth keeping an eye on how artificial intelligence tools are moving from research into potential clinical use, especially around microbiome analysis and early disease detection. The pace of this translation will matter a great deal. That's Planetterrian Daily for today. If you've been enjoying the show, a rating or review on Apple Podcasts or Spotify makes a real difference in helping new listeners find us. I'm Patrick in Vancouver. Thanks for listening, and I'll talk to you tomorrow. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.